want to do a short video to show you how to do the graph and the calculation you need to do for the lab about the rate of chemical reaction when you have the decomposition of the crystal violet. I already, as you can see on my screen here, I have the name of the data or the spreadsheet. Actually, what I'm doing is using Google Sheet rather than Excel. Why? Because it will be easier, faster to do any calculation. So what I did was collecting some of the data that I had. I ran the experiment 3 times at room temperature. And the same thing that you will see at room temperature, you have to repeat on uh, cold temperature. So here is the thing. I copy in one column the time and the absorbance. This absorbance was at room temperature, okay? Remember that the absorbance will be considered the concentration of the uh, reactant, which is the crystal violet, because we are keeping constant the concentration of hydroxide. So in order to do the first graph, which is finding out if this reaction is zero order, we need to graph on the y-axis concentration versus time. Let's do that. What I'm going to do is selecting all my data by I hold the left key of the mouse so I can select all the data at once and see if I can make a quick graph versus time versus concentration, or concentration, actually concentration versus time. So let me try and insert a chart, and here is what I have on the first chart. Let me close this. This is just a menu for fixing or improving the. So on the left side, on the y-axis, sorry, we had the concentration of the absorbance over time. Based on the graph, you go and check your textbook and all the slide presentation or the last class. Based on the graph, concentration versus time, it doesn't look zero. At least my first at room temperature, because it's not like a curve. So the next thing that I'm going to do is, let me move the graph out of my way because we need that. You need to make 3 graphs. So the next thing we are going to do is the following. I'm going to do now the calculation of the natural law of concentration, and will be graphing now. Natural law of concentration versus time, because that will give me the graph for first order reaction. So I'm going to do right here. So let me put a title. So that will be natural law of concentration of crystal violet, just for reference, okay? Let me close, okay. So that will be my calculation. How can I enter the formula? I will type equal sign, natural law, open parenthesis, and I will pick this number on the left here, which is my concentration, and then I close parenthesis and hit enter. And they do the first calculation. For doing the rest, you go to this side, to the corner, there is a small a square thing here, and then you will drag all the way down to do the rest of the calculation. So I will go all the way down. I have 200 minutes, 200 seconds only, because remember the version we were using was no, the prof was a live version, a free version. So the next graph will be y-axis, natural law of the absorbance versus time. Let's select the data. So I'm going to select all the time first. I'm going all the way to time. That will be my x-axis. And then I will go to the concentration. My way to select the concentration will be, I press Control key on my keyboard and going all the way down until I select all my concentration. Remember, the time is, as you see here, 199.48 because my software stopped at that time. And I will go again and insert a chart. And this is the chart that I go. Beautiful, right? That one looks like a first order reaction. But let's check second order reaction. So let me close this menu here. I'm moving my graph a little bit to the right so I can easily insert the next one. Those are the graphs that you have to do. So how can I find out graphically if the reaction is second order? Well, for second order, we have to do the following. Divide 1 over concentration of the crystal absorbance, so crystal concentration, crystal violet concentration. And the formula will be, I will place an equal sign here, and then I will say 1 divide this number on the left. Oh no, not that one. This one here, because that's my concentration. And then I will hit enter. And they say, do you want to autofill? Oh, that's a nice thing to. Thank you, Google. They do the. I don't have to drag the formula all the way down. They do that for me. You can see how the formula is all the way to the end. Okay, now again, we have to do the graph. I'm going to select even the title, so that will make my graph even more clear for understanding. And I will scroll down until I select all the time. And I will go all the way to the end, yeah. And then I will go up again, and I will select pressing Ctrl key, selecting all the way to the end. Okay. So next thing is just insert a graph, a chart or graph. And this is my second order graph, second order reaction. It doesn't look like a straight line, right? Check your textbook, check your note, and remember how the second order reaction should be the graph. So right now we have for room temperature, this graph, for the other one, for again room temperature, this graph, the one on the left is for second order reaction. This one is a graph for first order reaction. That's logarithm of the concentration versus time. And this one here, let me get the graph, I'm moving up. That will be my graph for zero order reaction. Now you have to decide what order is your reaction, at least based on your experimental data. To me, it looks more like a first order because this one is no straight line, and this one and the one that should be I don't know why it doesn't show me the other one. This one that I have here is also a curve. So the only straight line that I go on my data on my experiment was this one. So that's all I have for you guys. If you have any question, feel free to email me and I can explain you, or I can set an online meeting with you where I can explain you more about that. So see you in class. Bye now.